Hi everyone, in this video we'll look at the chemistry of alkali metals or your group 1 metals. You have learned about metals in primary school, in lower sec, as well as in the chapter of chemical bonding. Spend 30 seconds to pen down some of the properties of metals that you are familiar with. You'll probably recall that some of the properties that you know about metals is that they are good conductors of electricity, and that is because they have mobile electrons. And for those of you who take pure chemistry, you learn in metallic bonding that we have the electrostatic forces of attraction between the metal cations and the sea of delocalized electrons. So the presence of mobile electrons enable metals to conduct electricity. The second property that you probably recall is that they have generally a high melting point, and that's because they have strong electrostatic forces of attraction between the metal cations and the sea of delocalized electrons. Another unique property of metals is that they are malleable and ductile. So malleable means they can be hammered into different shapes. We have learned in the chapter of chemical bonding that the metal atoms are orderly arranged. So when a force is applied, the layers of atoms can slide over one another easily. So how are alkali metals different from the general metals that we know? I'm going to show you a video and you're going to tell me what are some characteristics that you observe that are unique to the alkali metals.
Here we have a small piece of sodium metal which you can see is quite malleable and easy to manipulate. It's very easy to bend and even squish it just using your fingers. So as I said before, the sodium is quite soft and you can see here that it's easily cut using a knife. The liquid around the metal is mineral oil that the sodium was stored in. You can see that once cut, the inside is a shiny silver. However, if left open to the air, it will quickly react and become dull again.
The sodium is stored in mineral oil to minimize reaction with the oxygen in the air. The sodium is a metal and is an excellent conductor of electricity. If we take a piece of the sodium metal and add it to water, we notice a much more rapid reaction with the water. Like lithium, the sodium is less dense than water and floats.
Looking at the data in the table below, you notice that the density of lithium, sodium, and potassium are below that of water. So if you were to put them in water, they actually float on the surface. Also, you notice that the melting point is rather low. In fact, for cesium, the melting point is just slightly above room temperature. And if you have a vial of cesium, you put it in your hand, the heat from your hand is enough to actually melt the metal. So you can already see that there are certain characteristics here, such as being soft, low density, and having a low melting point are quite characteristic of group 1 metals. What trends do you notice in the data here? The melting point decreases going down the group, so does the boiling point. The density, however, increases as you go down the group. In terms of their electronic configuration, all of them have one valence electron, and when they form ions, they lose that valence electron. So generally, when we group elements, those with the same number of valence electrons are put in the same group. To explain the melting and boiling point down the group, we then have to consider what kind of forces of attraction we need to overcome. For those of you taking pure chemistry, you will know that in metallic bonding, we are talking about the electrostatic forces of attraction between the metal cations and the sea of delocalized electrons. So if my valence electron is further away from the nucleus, the amount of electrostatic forces of attraction between them is actually lesser. Going down group 1, the size of atoms increase because we have more electron shells, and this will result in the valence electron being further away from the nucleus. As a result, going down the group, the amount of energy you need to overcome the electrostatic forces of attraction between the nucleus and the sea of delocalized electrons will decrease. Therefore, the melting point decreases down the group. Group 1 metals are known for being very reactive. In a chemical reaction involving the alkali metals, they will lose their valence electron to have the fully filled valence shell. Group 1 metals, they are very reactive, so they are stored in a layer of oil to prevent reaction with oxygen and water in the air. Again, going back to the electronic structure, the valence electron is further away from the nucleus going down the group. And if you can think of a chemical reaction as the atom losing its valence electron, then it will be much easier for potassium to lose its valence electron because the valence electron is further away from the nucleus. Okay? This is quite similar for the explanation for the trend in melting point. Amount of energy needed to overcome the electrostatic force of attraction between the nucleus and the valence electron decreases down the group. So the metals become more and more reactive down the group. So here's a link to redox reactions which you may or may not have learned yet. When we say that an element loses electrons, that element is oxidized. So loss of electron means oxidation. And by losing the electron, you're giving it to someone else, and you cause that other substance to be reduced. Okay, so this will be covered in the topic of redox reactions. So keep that in mind if you haven't learned that. And we say that group 1 elements tend to be strong reducing agents because they give electrons to something else, causing that other substance to be reduced. So the more willing you are to give the electron, the stronger your reducing power is. The classic example of a reaction involving group 1 metals is that of adding them to water. Let's watch the video of a reaction and tell me what you observe.
The metal moves across the surface being pushed by the hydrogen gas that is produced. As you go down the column with group 1 metals, the melting point of the metal decreases. The reaction is very exothermic, which causes the sodium metal to melt. The metal contracts into a very compact spherical form. We can again test that hydrogen gas is being produced by trapping the gas and testing its flammability.
We observe that the metal floats and it darts around the surface. We also see effervescence. The gas being produced is hydrogen gas. We can actually test that using a lighted splint. What is going on is that when the alkali metal reacts with water, it forms the respective metal hydroxide and hydrogen gas. So if we take lithium, for example, adding it to cold water, we form lithium hydroxide and hydrogen gas. Balance the equation. What happens if we add universal indicator to the solution? The universal indicator is actually green, but when added to the solution it turns purple because this is actually a strong alkali.
Got a nice water bath set up. I'm going to add some universal indicator and then stir it up. Potassium, like other alkali metals, will react with water, liberating hydrogen gas and creating a basic solution.
So let's jot down our observations. I'll now show you a video of the reaction between lithium, sodium and potassium with water, and you can compare the difference in their reactivity.
When placed in water, lithium metal reacts vigorously with water. Notice the bubbles of gas and the heat that is produced by the reaction. Let's take a look at sodium metal. A similar reaction occurs. However, notice that this time, the heat produced is strong enough to melt the sodium metal. The sodium metal becomes a ball of molten metal that floats on water. Finally, we have potassium. Like the other two metals, potassium metal is soft and shiny when cut as well. When placed in water, a similar reaction happens. However, notice this time, the heat of reaction produced is so strong that it produces a purple flame.
Notice how we use different words to describe the extent and the speed of reaction involving the three different metals and water. The second kind of reaction involving alkali metals is that with other non-metals, for example halogens or group 17 elements. We all know that metals react with non-metals to form ionic compounds. So one of the reaction involving a group 1 metal could be sodium reacting with chlorine to form the ionic compound sodium chloride. Let's watch this video. So we have a heated piece of sodium metal being put into a jar filled with chlorine gas. We see a very bright glow, and we also notice white fumes of sodium chloride that is formed. Let's write the equation. Sodium reacting with chlorine to form sodium chloride. In this reaction, sodium is being oxidized as it loses electrons to form sodium ions. These electrons are gained by chlorine to form the chloride ion. So this reaction involves the formation of an ionic compound. We have reached the checkpoint questions. Give them a try and I'll go through the answers with you. Question 1, the answer is B. Because cesium is a group 1 metal, it will form the soluble compound cesium hydroxide and hydrogen gas. Question 2, we are looking for a low melting point with low density. So the answer is C. The melting point cannot be below room temperature because your alkali metals are still solids. Question 3, we have lithium and we have cesium. We know that going down the group, the melting point decreases, but the reactivity increases. So element X is directly below lithium and Y is directly above cesium. X has a higher melting point than Y. That is correct. Option B is wrong because they all have one valence electron. The density of X should be lower because the density increases down the group, with water than Y because the reactivity increases down the group. Okay, question 4 is quite straightforward. The melting point decreases as we go down the group, proton number increase. The metallic character increases down the group because as you go down the group, the valence electron is further away from the nucleus, less energy is needed to remove it. Reactivity also increases down the group, and the atomic size increases because more electron shells. So that's all for group 1 elements. Make sure you know their unique physical properties, how to explain the trends, as well as how to explain the chemical reaction, especially that involving the alkali metal reaction with water, as well as with non-metals. So that's all for this video. I'll see you in class.